Landscapes formed by glacial erosion. Like water, ice can erode the landscape, and it does a fabulous job. Now, don't get me wrong, water does a truly fine job too, but if you want spectacular scenery, ask some ice to do its work. How does it work? Two processes, glacial abrasion and by plucking. Like water, it's capable of grinding away the rock that it travels over, but also it can pluck away pieces of rock and take it on their merry way. Let's start at the top. The top of the glacier is a circular area called a cirque. That's where the snow has accumulated and started to take away some of the rock. One way is by grabbing the rock and plucking it and carrying it away. Bye. There it's gone. Also, by doing so much erosion, it will cause the back of the cirque to be very, very steep. That steep wall is called a head wall. And if it's so steep, it will start breaking apart. Of course, there's a lot of freezing and thawing going on, and pieces of rock will fall down onto the cirque. The ice will carry it away, and now that it has all this sediment with it, it can start its second method of erosion called abrasion. Here we have some striated rock. We know that ice has gone over this rock. You can see the scratches and even tell the direction in which the ice flowed. Okay, I can't tell if it went that way or this way, but I know it didn't go that way. That would be just silly. So all of these scratches are called striations. It can even polish the rock smooth. Here are my lovely hiking boots sitting on top smoothly polished granite. The granite usually looks like that, all rough, but the ice has traveled over this spot up in the Sierras, polishing it as smooth as can be. Let's take another look at those cirques. As I said, they're circular areas located at the top of a glacier valley where the ice begins. Sometimes they'll have a cirque lake or a tarn in them. After the snow is all gone, that little depression is a great place to collect some water. Here we have some cirques. You can see how very steep they are. And here's a lovely cirque in the Sierras, one of the Kearsarge lakes. Notice the valley shape, totally different from a river valley. Here we have a very big U-shaped cross-section of the valley. Now, a glacial valley is easily distinguished from a river valley. If you saw a valley like that, you'd say, oh look, that must have been a young river that carved that valley. Or a valley like this, broad U-shaped valley, you'd say, oh look, that must have been an old river that laid down a floodplain and left us that valley. But if you saw a glacial valley, you would go, oh my, that is a valley. Look how steep the sides are. Look how deep it is. Now, it might have a little river in the bottom, but that little tiny river didn't carve that valley. That's a misfit stream, a stream that's flowing in a valley that was cut long ago by ice. So here we have a nice, broad, U-shaped glacial valley. You can see they're mighty pretty. Here's another one. And here's another one. But instead of just having one lake, a cirque lake at the top, it has a whole series of lakes, and they're strung together like a series of beads. Somebody thought that this series of beads reminded him of a rosary, which is a set of beads that people use to say their prayers, or their Our Father. Paternoster Lakes is the name given to this series of lakes in glacial valleys, named for a rosary. Here's a glacial valley, but it's hanging high above the main glacial trough. That's because tributary valleys like these deliver their ice to the top of the main glacier. They don't carve all the way down to meet the main glacial valley the way a river does. So here we have a tributary valley joining the main glacial valley. The main glacial valley is much deeper, so when the ice is gone, this tributary valley is hanging high above the original large glacier. That's what explains Bridal Veil Falls in Yosemite. Here we have the U-shaped valley of the tributary glacier hanging above the much larger Yosemite Valley with a beautiful waterfall. This is Bridal Veil Falls. Fjords. Fjords are long, skinny, narrow bays that were carved out by glaciers but have since been invaded by the ocean. Now, wait a minute. When a glacier hits the ocean, what happens to it? Yes, it breaks off into icebergs. So how is it we can have the ocean in a glacial valley? That doesn't make sense. Well, let's get a few clues to figure this out. Here we have the Tracy Arm Fjord in Alaska, and here are the two Sawyer glaciers coming to join it. But you can see a line right here. This red line has above it rough rock and below it polished rock. What polished that rock? Must have been ice. That indicates that these glaciers must have been much, much larger in the past. And in fact, they were. The past being the last ice age, at its greatest about 11,000 years ago. I took that picture way up here in the fjord looking at the Sawyer glaciers. But this fjord continues all the way down to the ocean. And there's evidence that ice filled it up to the brim until it reached the ocean, where it finally calved off into icebergs. Since then, all of these glaciers have melted. Well, where did all that meltwater go? It went into the ocean. So during the Ice Age, the sea level was much lower. And in fact, this would have been sea level. But since then, sea level is now all the way up this glacial fjord. Here are some more fjords, the fjords of Iceland. So every one of these bays is now at sea level, but they were once filled with glaciers. Horns. When a mountain is surrounded by cirques, it ends up having very, very steep sides and can often be turned into a very distinctive, sharp-edged mountain called a horn. This is not just a horn, this is the Matterhorn. Of course, you may be a little more familiar with the Matterhorn you can find in Disneyland. Arêtes. Arêtes are very, very steep-sided ridges that are between glacial valleys. The glacier has eroded steeply on each side of it, leaving this sharp ridge behind. Those of you who know your French know that arête means stop, and certainly if you are hiking in this area, an arête would do an excellent job of stopping you. So let's see what you've learned. What is this structure? It's called Ptarmigan Lake, but it is, of course, a cirque with a lake in it, or a cirque lake. This is Yosemite Valley. This is the glacial valley, and here's that little hanging valley coming into it. Now, Yosemite Valley was a mystery to those 150 years ago. Whitney thought it was the result of a giant earthquake tearing the earth apart, but it was John Muir who had traveled up in Alaska, looked at those glaciers, and came back to his beloved Yosemite Valley and decided that it was formed by glaciers. He was, of course, right. Here's another view of Yosemite Valley, steep side, so steep that half of a granite dome fell into it, leaving behind, you guessed it, Half Dome. If you've never heard of John Muir or Half Dome, shame on you. All you have to do is take out a California quarter, and you'll find John Muir and Half Dome of Yosemite Valley there for you to admire. What do we have here? Oh yeah, another cirque. And I don't know about you, but I see a horn. So let's see. The yellow here, what do you think? Oh yeah, Hanging Valley. Here's the main glacial valley, glacial trough. Here we have a ridge between two valleys. That would be an arête. Here we have a steep mountain, a horn. Circular area at the top of a glacial valley. That would be the cirque. And a series of lakes going down. Those lakes are Paternoster Lakes. So that's it. You have learned the landscape of glacial erosion. We're done. I don't know about you, but I'm now in search of a snack. Bye.